Assalamualaikum warahmatullahi wabarakatuh. Thank you for your attention and thank you for PJB Connect 2020 that give us opportunity to share our experience at Arun Gas Engine Power Plant. At this case, we titled Surging Phenomenon in Gas Engine Crankcase. The paper has been written by Mr. Verry Mardiananta Arsana, Mr. Rahmat Reza Riski, and Mr. Purnama Wahyudi. Let's see, the slideshow is about, firstly, we want to share about internal combustion engine. What is internal combustion engine? The internal combustion engine is an equipment that functions to convert the chemical energy which contain fuel to become mechanical energy. Its process occurs in a closed combustion chamber, make translational movement of the piston into rotating motion that will rotate the generator. As we can see image beside, this is the generator and this is the crankshaft and this is the combustion chamber that makes translational movement to the crankshaft through the generator or rotate the generator. Next, introduction about Otto Cycle. What is Otto Cycle? Otto Cycle is internal combustion that work based on 4-stroke. There is 6 steps on 4-stroke engine or Otto Cycle. First is step 0 to 1, and that means our step of suction, which occur a constant pressure or pressure. This is the intake stroke. And then the second step is step 1 to step 2. Our compression, this is the compression stroke in isentropic condition. And then the third, step 2 to 3 is considered as a constant volume heat intake process. As we can see here, number 2 and number 3 is the constant value to take heat intake process. And then the fourth, step 3 to the 4th are expansion process. Number 3 to the 4 is the expansion process, which occur isentropically. And then the step 4 to the 1 are step of releasing heat at constant volume. And then the last is step 1 to 0, are constant pressure process. Are constant pressure processes. As we can see here, this is the 4-stroke engine. First is intake stroke, and then the second is compression stroke, and then the third is power or expansion stroke, and then the last is exhaust stroke. Blow-by gas. What is blow-by gas? Blow-by gas is accumulated gas inside the crankcase must be removed to prevent crankcase explosion and to protect the engine against bigger mechanical damage. Blow-by gas is actually an event of gas escaping from the piston ring and into the crankcase. The piston ring has a function to insulate the combustion chamber, to prevent compression leaks, and also prevent gas from entering the crankcase. As we can see image here, this is the compression that in combustion chamber, and the blow-by gas will through the ring piston, through the crankcase and makes crankcase pressure is positive. For the mechanism is we can see here, this is the compression that makes gas is blow by. We can see here this is the piston and this is the compression and makes the gas is blow by to the through the piston and ring piston into the crankcase. As you can see here, the combustion chamber makes the power until 150 bar, and the blow by gas will come in through the ring piston and piston through the crankshaft here. As you can see here, This is the image of the engine. When the blow-by gas is coming through the crankshaft will be positive, and it should be ventilation or flow out through the crankcase to isolate or not make a bigger damage in the crankcase. As you can see here, this is the ventilation pipe through the atmosphere. This is what we call about crankcase ventilation. The crankcase ventilation system is a channel that connects the room in the engine or crankcase engine with outlet plus minus 20 meters. As you can see here, this is the exhaust ventilation, and this is the oil mist separator, and this is the inlet valve, and this is the coupling. For the diagram here, this is the crankshaft, and the ventilation out divide into two directions through the coupling and the bypass pipe and goes to the atmosphere. And the second is inlet valve through the, you can see here, oil mist separator, that the functions is to reduce the moisture of the oil, and then the good oil will come back to oil outlet, back to the crankcase or oil sump. And then after the oil mist, the ventilation goes out through the atmosphere. This is the normal crankcase pressure. As we can see the graphic or diagram here, normal operation crankcase pressure is about plus minus 0.02 millibars at 8.8 megawatt. As you can see here, the black color is the load. It means 8.8. This is the fans. This is the fans. The load is 8.8 constant, and then this is the crankcase pressure for the green one, the green line. The pressure is constant minus 0.02. This is the normal crankcase pressure. And for this is the example for abnormal or surging phenomenon in gas engine crankcase. As you can see here, this is the crankcase pressure that should be normal minus 0.002. It raised until minus 6.29. So what is the surging phenomenon? Surging phenomenon when the pressure has reached the maximum vacuum point to the engine crankcase, then suddenly had a back pressure which causes the pressure rise up inside the crankcase suddenly. We can see there is a four step here. First, when the engine at below 8 megawatt and the pressure crankcase, the green one, is stably normal. But at number 2, we can see here the crankcase pressure is raised and then drop until we can see here number 3, minus 6.29 millibar. Suddenly the crankcase pressure is raised until number 4, the maximum point, the engine protection point. This is about 5.57 millibar, and then go raise until the pressure is pressure 25 millibar. It means same the atmosphere or the height of the ventilation pipe. And then before at number four here, we can see the engine protection point is 5.57 millibar and drop and makes the engine trip, but the pressure crankcase is still rising until stuck, and then drop until normal normal condition. But the engine is tripped first. That's the surging phenomenon in gas engine. From that case, we have a root cause. First, about the factor causing this phenomenon is due to a leakage of hot exhaust gas plus minus 500 degrees burst to the surface of ventilation pipe and increasing the temperature of the gas in the vent pipe, thereby decreasing its density. As we can see here, the exhaust temperature is about 525, and when we check with the thermograph, it's about 505 degrees in the expansion below, and we can see there is a leak, the expansion below, and this is the actual picture. This is the ventilation pipe, as you can see, the elbow, and this is the billows where the below is leak and hit or burst the ventilation pipe. So it makes the temperature in the vacuum pipe or the ventilation line is rising. So for the conclusion for our paper is first, exhaust gas leak burst to the ventilation pipe. It can make surging phenomenon in the crankcase, like we said at the slide before in the abnormal condition. And then the second is it was preceded by a crankcase pressure decrease from operating pressure, minus 0.02 to minus 2 millibar, to a critical pressure about minus 6.29 millibar. It's also at the slide that we have explained. And then the third is, after the critical vacuum pressure reach, surging phenomenon occurs when the outside air is drawn back into crankcase. And then the last is it causes the crankcase pressure to rise suddenly up to 25 millibar and makes gas engine drip. So that's the conclusion from our paper. We hope our case that happened in gas engine power plant makes function or not makes the engine crankcase pressure broke. That's all. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.